Okay, I think it's happy now, hopefully.
Let's see, so coming back to this again, yeah, let's not use just brute force on this, let's use the Fermat's Little theorem. So we already know that 7 to the 18th is going to be 1. So something like 2006 divided by 18, totally within the realm of something I would want you to just be able to scribble down. So it goes in once, subtract 18, it goes in once again, and then we have 26 here, so we put it in one more time with a remainder of 8. So this is 7 to the 18th to the 111th times 7 to the 8th, right? I'm just going to leave off the mod 19 at this point. So the multiples of 18 all cancel out, right? So we're only left with 7 to the 8th, which is 49 to the, now we can start reducing it. So this is 49 to the 4th, but 49 can be reduced in the world of mod 19 to what? 11, right? So this is 11 to the 4th. 11 is actually better if we rewrite it as negative 8. And then since I'm taking a 4th power, I may as well make it a positive 8. Okay, so you can just cancel off the minus sign, write it as 8 to the 4th. Okay, so we need to do 8 times 8. That would be 64, which in the world of mod 19 is what? So this is
7.
64 squared. 64, yeah, mod 19 is 7 because 19 times 3 is 57. So if I take 57 away from 64, I'm left with just 7. So I end up getting 49, which actually comes back to 11 again. Yeah, and that's mod 19. Okay, so my second equation is x is congruent to 11 mod 19. You'd be more than welcome to change that to negative 8 if you wanted, because it's in mod 19, and sometimes people like the smaller numbers, but I'll just leave it as 11. Okay, am I going too fast? Just trying to wrap this up, because I think you guys know how to do these. And then the last one is going to be mod 25, I think?
Yep.
Okay. I just want to make sure I'm getting the right numbers. Yep, so far so good. Okay, so mod 25 would be the last one, so 7 to the 2006. Now 25 is not prime. See how this problem is really a nice, you have to use the Fermat's Little theorem a little bit, but you can't just do that. You have to also do some calculations. So in mod 25,
Well, like him,
it's not prime.
doesn't have to. What is
Well, you could, if you want to use the Euler's phi function, the stuff from chapter 7, I guess you could use that, which would be mod 20. Phi of 25 is 20, but I'm not requiring you to know that. So, yeah, what I would do here is just say if you square the 7, you get 49, right, which is negative 1. So this is 7 squared to the 1003, right, which is negative 1 to the 1003, because 49 is the same as negative 1. And now that's an odd number of negative 1s, so there you go. You got the whole thing. So you have negative 1. So then the last one in the system is x congruent to negative 1 mod 25. So we've generated our system over there. So this is a nice, I mean, this problem would be like a lot of points. Like this would be 15 or 20 points probably to do all of this stuff. It would be a big chunk of the test would just be this one problem. So then the next thing would just be to solve that system over there. And you'll get a unique solution modulo 3800. This is what you're looking for. You actually have to come up with a positive answer. There were some people, I think on the last homework, who were giving me remainders that were negative numbers. The remainders have to be between 0 and, in this case, 3799. Right, they have to be in that interval. So the Chinese remainder theorem might spit out a number that's not in the range that we want, and we will have to make an adjustment to get the one that we want, right? So the last thing to review tonight, and I'll feel good about the review if I actually write it down, because I haven't written it down yet, which is the formula for the solution to the CRT. This, of course, if you're learning the proof of the Chinese Remainder theorem, because it is one of the proofs, then you already are reviewing it while you learn that proof. But if for some reason you're not studying that one, you definitely still want to know the solution. Does everybody know it? A1, N1, Y1, right? A2, N2. You guys have it. In this case, we have 3 terms, okay? 3 terms to the solution here. So we have to figure out some of these numbers, oh boy. Let's see here. How do you figure out, question?
If we write all that up, we have to specify mod 300.
Oh yeah, I should do that. This is modulo 3800. How do you figure out, okay, so N1, may as well teach you a little bit about doing mental arithmetic here as long as I can. Was anybody here a few years ago when Art Benjamin came over? Did you go to that?
Yes.
The guy can multiply 2 3-digit numbers in his head in 5 seconds or less. Probably 2 seconds or less. He's a mathematician. He's actually a professor over at Harvey Med College, and so he's very, very good with this stuff. And he came over and sold a bunch of books. Doesn't the Math Club have a couple of his books on the shelf? So ask Derek, he might check them out to you to study for Monday. You want to do fast mental arithmetic. Anyway, what I do, since I'm not that great, is I just look at this. So for N1, I'm going to multiply 25 times 19. I literally just think of that as 25 times 20 minus 25. So in other words, 19 is just 20 minus 1. So this is the way I calculate 25 times 19. And so 25 times 20 is 500. That's pretty easy. And I subtract 25 from it, and I get 475. Did I do it right? Hope so. I'm bragging about the technique. It better be right. Okay. Let's see. N2, for that I multiply the first and last mod, so 25 times 8 would be $2. That's just $200. And N3 would be 19 times 8. Oh, I do 19 times 10 and I get 190, and then I have to subtract 19 twice from that, so I have to subtract 38 from that, from 190, which is 152. Yeah. You can take a little longer and write it down, it's okay. I'm just trying to do it in my head so we can get out of here. So those are the numbers. And now we have to do the Y1, Y2, Y3 part. Oh goodness. So remember how that works. We have to do N1, Y1, congruent to 1 mod little n1. And we have all of these equations to write down. So, oh boy, 475 times Y1 congruent to 1 modulo 8. Okay, so what am I going to do to figure that out?
Reduce 475.
I have to divide 475 into 8. Unfortunately, I'm not as good with division, so I'll write this down. So,
And you know, 400 is going to be
480.
480, and then divide by 2.
oh, this is, okay, so 480 and I'm 5 less than that, so it would be negative 5. Alright, I'll go along with that. And that's the same as 3, positive 3, y congruent to 1 mod 8. And so, hey guys, if you get to this point, I'm perfectly fine with inspection here. So you don't have to say, oh, I have to use the Euclidean algorithm forward and backwards to write the GCD of 3 and 8 and then solve it. If you could just, when you're in mod 8, you don't have very many numbers to try. I could believe that you would brute force that and just try every number, and you quickly see that 3 works, right? So y1 is congruent to 3 mod 8. Okay, so there's one getting there, okay? All right, tell you what, I need a little line right here. You guys on this side, figure out what y2 is, and you guys on this side, figure out what y3 is, and that way we'll like go twice as fast.
Y2, 2.
Oh. This wasn't a race. But everybody take a moment, see if you can figure out the rest of the numbers. I'll stand up here and try and do it myself for a second. So on the case of the Y2, it's really easy because 200 and 19 are kind of easy to work with. 200 is 10 more than 190, so we just subtract 190, we just get 10. And then by inspection, you can see that 2 works. Okay, that's easy. Third one, did anybody on this side figure it out yet? 13. Oh, that sounds like it might have been a little tougher, because you have 152 times y3 is congruent to 1. Of course, this is the biggest mod. Oh, this isn't so bad. I was thinking it would be, but it's not, because 152 is just 2. Sorry, I didn't mean to make it sound like it's going to be hard. This is not bad. Okay, again, by inspection, y3 equals 13. Okay? So there you go. So now you're going to have all of these numbers, and make sure you write them on there. So now you just plug into the formula, right? So we're going to get a final answer of 1 times 475 times y1 is 3 plus 11 times 200 times 2, and then plus negative 1 times 152 times 13. Okay, you know what? Probably I would accept it like that. Yeah.
So what if, when that happens, it's not positive?
Right, if it's not positive, then to get the remainder, what you'd have to do is,
But, so are you gonna accept it like that?
well, it would depend on what the question was. If I
Okay.
said find the remainder, I would actually not accept that, because that's
Okay.
not a remainder. I would have to phrase the question in such a way, if I wanted to do a CRT problem of this nature, and I didn't care if you left it like that, I would have to phrase the question differently. Let me see, what did I actually say on my solutions to that?
Is that something during the exam if we're not sure whether or not we can leave it like
You
that?
can ask me. Yeah, you can ask me. I'm gonna just be up here doing nothing, so. You may as well ask me, what was my solution to that? I'm sure that all I did was, oh yeah, I just,
don't think it turns out to you.
the answer, well,
But it might be above your mod, well, not in this
the
case,
answer,
but
this comes
sometimes
out to
it would
be
above your mod.
3,849.
So it's above, so it's 49.
So, right, so it is, the answer is 49. Yeah, that would take a little bit of work. I mean, honestly, I'm not going to be too interested in seeing you work all that out. If you have questions about whether you have to reduce something, if it's not, I always try to make my questions clear because I don't like to inspire a whole lot of questions during the test. But if it's not clear, you should come ask me during the test. It's probably not going to be a big deal to me. So I did quite a few things. You know, there's always 1 or 2 things I could also do. But you guys know your divisibility tests? Is a number divisible by 2? Is it divisible by 3? Is it divisible by 4? Is it divisible by 5? 6? You can skip 7. 8, 9, 10, 11, 12. Those are all doable. 7 is tough and 13 is tough. But the first 12 numbers, most of them you got a nice divisibility test. Remember, if you had something like 12, I want to know if a number is divisible by 12. Just see, is it divisible by 3 and is it divisible by 4? It has to be both. And 3 and 4 are solved with other tests, simpler tests. Yeah?
For the divisibility of 8, is
Yeah.
it you look at the first 3 digits?
Yeah.
Oh,
Yeah.
or the last
You take the
three-
last,
three,
the 3 digits farthest to the right and see whether that 3-digit number is divisible by 8. That's true. That's true. All right, guys. Well, I'm all out of ideas for anything for tonight. If you have questions, feel free to shoot me a Facebook note or an email. I'll be around all weekend, obviously, so I'm happy to help out. Feel free to come on by.
I think we're gonna move that next time.
Thank you very much. I would love to
I
make
brought
a copy of
some
it.
other
Just a
stuff that I
second.
can do.
Just turn this
Also, if there's pizza left, go ahead and grab some.
I might just